Yes, my names are Matthews Nondo. I want to take you through in industrial organization and management, and the topic is network analysis, that is project engineering technique. I will start by introduction. Network analysis is also known as project engineering technique. It is a combination of activities, including dummy activities and events, drawn in a logical sequence according to the rules for the construction of network. Now, before we study the rules for the construction of network, I want us to know some of the terminologies which are used in network analysis. The first terminology which is used in network analysis is activity. Activity in project planning, what we are doing now, is an occupation which has got its starting time, ending time, obviously duration, and cost. That is what is known as activity. The second terminology which we'll be studying here, which you are supposed to know in the network analysis, is an event. An event is a time description. Event is this one. Event is a time description which is given for the starting and the ending time for an activity. So basically, activity has got two events, that is starting and the ending time. Then another terminology which we'll be studying and using in network analysis is float. Float is a spare time taken by or calculated on the activities which do not exist along the critical path. The activities which do not exist along the critical path, they have what is known as floats. Later we'll be studying the types of floats as we start drawing network with the help of the time estimates. Then the next, which is almost similar to float, is slack, but there is a difference. Slack is a spare time taken by events. The other one was an activity. Slack is a spare time taken by events which do not exist along the critical path. Now, the other terminology which is very much essential, and we'll go to the extent of determining it in a project, is the critical path. Critical path is defined as the path which contains sequence of activities and events which determine the total project duration. It is the longest path in a network and consumes more time and resources. So critical path will determine the total project duration. So the other terminology is known as preceding activities or preceding activity. Preceding activities in a network are the activities which occur earlier than others. In fact, they give rise to the occurrence of other activities. Then the other terminology is succeeding activities. These are activities which occur after the occurrence of other activities. They are also known as predecessors. So they are also known as successors. They are also known as successors in a network. Then the other terminology is known as dummy, which we will be determining in a project. Dummy activities. Dummy activities are the activities in a network which occur simultaneously at the same time, and they do not consume time or resources. In a network diagram, we always represent dummy activities using dotted arrows, as we will see later in the next lesson. Now, these are basically the terminologies which we will be using in network analysis. Now, before we move to how to construct network, we must study the rules. Now, these are the rules are the ones going to guide us when we construct network. And when we don't follow those rules, we will be constructing wrong diagrams. You see, so the first rule in the construction of network is networks are drawn from left to right, having one entry point and one exit point. They are drawn from left to right, having one entry point and one exit point. So basically, this is a general outlook of a network. So you will find they are drawn from left to right, having one entry point. This is the entry point, and this is the exit point. So under normal circumstances, we must number those points. So this is normally known as the exit point. This is known as the entry point. That is the first rule in the construction of network. So the second rule in the construction of network is networks must be represented by arrows. They must be represented by arrows from left, right. These arrows are always straight lines. And the other rule is they must be indicated by capital letters, but at times by numbers. Capital letters like A represents activity, B represents another activity, C represents another activity, D represents another activity, E, and for that network diagram, the last activity to occur is activity F. So activity A is regarded to be the preceding activity to activity B and C. That means activity A occurs earlier than B and C, or it gives rise to the occurrence of B and C. Then B is a preceding activity to activity D. Then C is a preceding activity to activity E. Then D and E occur at the same time. They converge to give rise to F. Another rule for the construction of network is networks, the arrows which are used must not cross each other. So we don't need to draw a network when the arrows are crossing each other. Then another rule for the construction of network is we must use straight arrows in the construction of network. So the arrows should not be bent. So when you draw a network like this one here, this is a wrong network which is not required. So the arrows must be straight, but because this is for just demonstration, when we start constructing network using time estimates, and that is duration, we will be drawing straight arrows. Then another rule for the construction of network is networks should not be drawn with the dangling activities. Dangling activities are the activities which are not connected to the rest in a network, and in fact they are hanging. Now the following diagram, the following network diagram now shows the dangling, the network diagram shows the dangling activity. So when you draw network like this, then you draw another activity going in another direction, different from the flow of the activities. This is a dangling activity, and let us just name it G. So G is a dangling. Dangling is this. Dangling, G is a dangling activity. So when you draw a network like this one, with this one hanging, let us say this is 7, then the whole network is invalid because this G is moving in a different direction. Now, another rule for the construction of network is do not construct network using activities which exist in form of loops. Activities which exist in form of loops, this is when a network diagram is drawn from left to right. Then the activities again, by the indication of the arrows, they move back to left. So from left to right, going back again to left. Then that is, those are the activities which exist in form of loops. Now the following network diagram will show you the activities which are existing in form of loops. It is just this, the arrows from A, this is B, this is C, this is D, this is E, but the arrows will change. So this is, it is moving from left to right, then again it is moving to left. So these ones, the network is drawn like this. Then when it moves again back, then that is what is known as loops. Then the next thing is we must know now how to construct network diagram. You see, using now the actual examples. But before we do that, we must know what is the essence of studying network analysis. Yeah, what is the benefit of studying network analysis in life? One, the following are the benefits. One, network analysis is used in setting computer programs. It is used in computer programming. You see, and it's a very essential tool when you set different programs for the computer. Then another thing, number two, it is used in initiating different projects of the organization and estimating the cost and the time they will be taking for their completion. Then another importance of network analysis, it is a tactful military method which is used for planning and scheming, and the mechanism for doing this, we will spare this for next time. Then another benefit of network analysis is it is used in construction of bridges, roads, and superhighways. That is the concept, is used in construction of roads, bridges, even the superhighways. Then network analysis is also a very essential tool in organization to make sure that the projects which are started are completed on time without being left halfway or at a certain level. Then we are going to construct network. We are going to construct network using various examples. I'm going to show you how to construct network analysis or network diagrams. So let us say this is example 1. Example 1, a project is installed. A company has installed a project, a small project, whose activities are indicated below. Let us say a project that is activity, then preceding activity, that is, let us say, example 1. So let us say a small project has got the activities indicated. Then we are asked to construct network. So the first one is A is giving rise to B. Sorry, A is giving rise to B. Then B is giving rise to D. Sorry, change this. Is it okay? B is giving rise to D. Then B, if it is giving rise to D, that means B is a preceding activity to activity what? Activity D. Then C is a preceding activity to activity E. Then D and E are converging to give rise to the final activity, activity F. So this one is the network diagram for the question, such that A is this dash can also mean none. That means there is no any other activity which occurs earlier than A and B. And in other words, A is the first activity to occur. And after the occurrence of A is giving rise to B. A is giving rise to B, and A is giving rise to C. A is giving rise to C. Then B is a preceding activity to activity D. That means B is giving rise to D, B is giving rise to D, and C is giving rise to E, C is giving rise to E. Then D and E gives, both of them give rise to, they give rise to F, which is the final activity now in that project. Now, the next thing which is left here is we must number the events. Events are numbered using a very basic sequence from left to right, using a very basic pattern. That is, this is 1, 2, 3. If they were existing in the same plane, this one could have been 3 or 4 or 3, 4. But since this one is almost occurring earlier, we have that basic rule of writing here 2, then this is 3, then this is 4. This is after 4, this is 5, and this is what? 6. So that is when the network is complete. And that is a network which is drawn when the duration is not still indicated. This one is a network with no duration, because this one is the basic stage of construction of network. Later we'll know how to construct network using the time estimates. So let us do example 2. And yeah. Is it okay? Now, this is example 2. Let us see how to draw the network diagram for that project. So activity A, preceding activities dash, that means activity A is the first to occur in that project. So there must be one entry point, as we had said. That is A. Then this node indicates that A is being completed, and there are other activities which are following A. A is giving rise to B. A is giving rise to C. A is giving rise to D. There are 3 activities which occur immediately after the completion of A. So we want to present these in a network diagram. This is B. This is C. And this is D. Then the nodes. That is, B, C, and D are occurring after A. So B is now giving rise to E. B is giving rise to E. After B, there is E. This is E. Then arrows must be indicated. Then after C, there is what? There is F. But E and F are converging. E and F are converging, and therefore C must just F must just go all the way to meet with the E. That is EF. So C is giving rise to F. Then that E and F, after they have converged, they give rise to E and F. Both of them give rise to I. Then we go back up here. C is giving rise to G. C is a preceding activity to activity G. C is a preceding activity to activity G. G is here. Then we draw node, which represents the completion for that activity G. Then, according to this, the information C and D are converging to give rise to H, which converges with the G. So C and D are activities which had occurred simultaneously at the same time. B, they are occurring from here, B, C, and D. So C and D again cannot converge because they are occurring at the same time simultaneously. These are activities which are known as dummy. So you represent them in a network, that is C is converging with D because they are occurring at the same time. If they are to converge, that is represented by a dotted arrow, that is dummy activities. So C and D are converging to give rise to H, and H, C and D are converging to give rise to H, and G and H are converging to give rise to J. That means EH ambayo inatoka hapa, which comes from here, this H which comes from here must converge with the G. So that means G and H are converging to give rise to J, and I and J are converging. So that J must go all the way to meet with I. That is J here, I and J, to give rise to K, which is the last activity so far in the project. So let me use this space for that node. So that is this one here. Then you draw this, then you draw This is K. So that is I and J. I and J are giving rise to K. And therefore, we number the events. Events are numbered from left to right. 1, 2, let us say this is 3, 4, 5. Then 6, 7, 8, 9. That is the solution. That is the solution. So this question, this is the network diagram. Yeah. Let me show you how to do example now, example 3. Yeah. Example 3. This is now example 3. This has got a small difference between the first 2 examples which we have constructed. For this example, this question, the activities are represented by numbers. You can see 1 to 2. The other examples were represented by capital letters. That is A, B, C, D, and so on. So this is this one we have to use the same technique to construct network. But this one will be directed by the flow of the activities. Like activity 1 to 2, when we represent this, the network becomes this is activity 1, 2 to 2. This is activity 1 to 2. Then you draw the arrow. This side we'll use when we'll be constructing network with the help of the duration. But for the time being, we are only going to use the first the first column in construction of network. Then this one we'll spare that for next time. 1 to 2, then 1 to 3. 1 to 3, you draw this. 1 to 3. Then 1 to 4. 1 to 4. So this is the node for 1 to 4. Sorry. 1 to 4. 1 to 4. then 2 to 4, 2 to 4, then 3 to 4, 3 to 4. And that one gives us the solution for the question. That is, this is the network diagram for this. This one, this type looks simpler as compared to the first two examples which I have. Immediately I come. So now, this is example 4 of how now to construct network. Activity A preceding activities none, activity B preceding activities none, activity C preceding activities A. So this is the diagram representing that network. So that project, sorry, this is the network diagram for that project. Must be one entry point. That is A. B. So the arrows must be indicated. That is A and B. Then A is giving rise to C. A is giving rise to C. A is giving rise to C. But B and C are converging. So A must be C inatoka hapa from A, that is C, which converges with B and C to give rise to F. Activity F inatoka hapo. This is F. It's giving rise to F. Then the node must be indicated. Then that is B and C giving rise to F. Then A is giving rise to D. A is giving rise to D. A is a preceding activity to activity D. So this one, toka hapa. Then A is a preceding activity to activity E. A is a preceding activity to activity AE. That means E is coming from A, but it is going to converge with the EF. EF, F is here, so it is going to converge with F. So that is, it is E is converging with F, and D is giving rise to G. D is giving rise to G. D is a preceding activity to activity what? Activity G. So that means EF and G, or GEF, or FEG, that is EFG is giving rise to what? To activity F, to activity H, sorry, activity H. So that is H is here, and this is the node for the completion of that H. And since H is the last activity in the project, this node indicates that the project has been completed there. Then we number the events. That is 1, 2, 3, 4, 5, and 6. That is the solution for this example 4. Yes.